Okay, it's 6 o'clock somewhere, everybody. It's 6 o'clock here. Hey, everybody. Well, welcome to week 2 of Advanced Programming with Java here at Portland State. Okay, I think we finally got all of the enrollment stuff squared away. So those of you who are on the wait list, I think everybody's registered or is about to be registered. So I think we're all squared away there. But please, for your own benefit, double check Banner to make sure that you're still registered and nothing's gotten messed up. I think so. We have a couple more days before it gets incredibly difficult to make changes. So let me know if there's anything else that you need there. So good deal. So let me just quick talk about what we're going to talk about tonight. And also I see quiz 1 is due. I know there are some of you who just got enrolled today, probably didn't have time to do the quiz. Please reach out to me, and I'll extend it for a little while for people, and we can get all that squared away, and then I'll have the graders grade that on Friday or over the weekend. So tonight we'll start out with just a little bit of Q&A. I want to dedicate some time to that. If you guys have any questions, we had some good discussions at office hours. I think there were a couple people that were sort of stuck on some fundamental things. We got them moving forward. So if you're also in that situation, we can talk about that for a little bit. Tonight I want to focus on test-driven development. I felt we sort of shortchanged that last week because we had all that administrivia in the beginning to talk about registration and stuff. So I want to focus most of our time here tonight. I'll be showing you test-driven development, and I want to then engage in a conversation about what you're seeing and what it is that I'm showing you. We also have some stuff related to your projects to talk about tonight. So we'll talk about the expectations for how your projects are documented, and then also the process by which that you submit your projects to me for grading. And then we'll assign the second project. So after tonight, you'll have 3 projects in progress. You've got Project 1, which I think a lot of you have already started. You've got the cones, which is a long-running thing that's not due for a couple more weeks, but something that I recommend that you invest a little bit of time in every week to make sure that you're that you get there by the finish line. And then we'll be seeing Project 2. Time permitting, and based on how we feel, we might talk about some pair programming tonight, but maybe we'll save that until next week. So to start us off, though, what questions do you have? Or questions or observations that you have about what you've experienced over the last week working with Java and doing some of these advanced programming things? Is everybody gotten at least their Maven project for Project 1 to build? I'm seeing a couple of no's out there. For the people that haven't got to running, is there a specific hurdle that you've faced, something you'd like to talk about? Just haven't gotten around to it because it's not due for another week?
I have a question.
Yes, okay, yeah.
So you said on the description of the project, you said we don't need to modify your code, but it seems like we need to just delete some unimplemented stuff, and we need to implement the actual method. So there is maybe unclear.
Yes,
exactly
so the
modify
the code, right. By modify my code, I mean the one that's in my package. So not the code that the archetype creates for you, which would be your Project 1 and the airline, right, the flight. Right, that's actually in your package, so I consider that your code, but you're right. Actually, that comes when I originally gave that project. They didn't have. It was before I had the archetype, and so they really did start from scratch. The archetype, I think, gets you a lot of the way there, and so then. But yes, so stuff that the project that the archetype generated, that is your code. That's what you should be modifying. Someone at office hours though did ask about modifying the POM to add new dependencies to do command line parsing. Nope. So when I grade it, what I do is I take the archetype, I generate a new project with your ID from the archetype. I blow away all the source code, I blow away all the test code, but I keep the POM. No, you can't add more dependencies. If you really think that you need to, send me an email, we can talk about it, but you should be able to do everything that you need to do with just the raw Java API, whether it's the plain old Java APIs. Okay.
Your methods that were overriding, they're in the package on the GitHub that we download.
There's several ways of getting those. Right, you can see the source code on GitHub. Also through Maven, I also published the source code to a jar on my Maven repository, so that should allow IntelliJ to like browse right to it. So like if you click on abstract flight, it should bring up the source code. Let me know if it doesn't. I'm seeing a couple of nodding, so I think it works for some people. Got that to work. And then there was a third way. There was a post about that on the Google community. Is everybody on the Google community? Hope so. Yeah, excellent, good deal. So someone. I got one thing. Let's see here. What was that? What was that called? Someone. Moderate. Is someone the tourist, or is this spam? No, I mean, hey, if you're online and you're the tourist or whatever, that's cool. But is this someone who's in the class? If not, I'm going to reject them because I don't want no tourists in my class. Apart from California or something, I don't know. Julie, thank you for joining. Okay, cool. So yeah, everybody in the community, please feel free to ask questions. Yeah.
Is there a specific way, like data structure, you want us to use, or any words? And do we put the name of the airline in the flight or the airline?
Okay. So two questions. One was you mean the data structure to hold the flights in the airline? So this is part of the assignment. So I think I specified that it has to be a collection. Go figure out what a collection is and choose your favorite one that will work. It's also covered in, let's see here, in gory detail in the core language APIs lecture. So you can learn about all sorts of different kinds of classes that implement the collection interface. So choose the one that works for you there. And the question about where the name of the flight lives, the name of the airline lives, that's part of the assignment also, is to figure out how do you want to design your code, where does it make sense, what are the separation of responsibilities between the flight class and the airline class. Truth be told, I'm just going to test what your command line does. With so many of you, we can't afford to be looking at your code and provide you feedback. If you really like feedback on your design, maybe once we get a little more into the course and you've made more design decisions, I'd be happy to entertain you in a conversation about it, or maybe put something if you have something up on GitHub, open it up to me so I can make some comments. That would be cool. And if you have questions, more detailed ones. So maybe after you've made a decision about a design, it's like, hey, this is a good design. Send me an email, or put something on the Google community, and we can have a discussion there. How's that for a non-answer? Yeah. Okay. Any other questions? Things you learned? Okay. Cones. Got those up? Are they working for everybody? 'Cause in the past, it's some okay. So there have been some terms where it's been hard for people to get off the ground, things not running correctly, but it's running correctly for everybody. Again, it might not be due for a few more weeks, but get started now because you don't want to have to be up there, until the strange hours of the morning trying to figure out all of this stuff. Cool. Okay. Okay. Let's do some test-driven development. Where do I want to go? Okay. Abstract airline. Oh, so yesterday I threw together a little bonus screencast that was all about continuous integration, and if you have 40 minutes, I recommend that you check it out. So continuous integration. I use this tool called this cloud service called Travis CI, Travis Continuous Integration, and basically what that gives me is a service that listens for changes to my GitHub repository, and every time there's a change, every time I push some new code up to GitHub, it will go and check out the code, rebuild all my code, run my tests, and make sure everything's still working. And so this is cool because it gives me rapid feedback in case I break something, and also make sure that the code is run in a clean room environment. In order to do that, I messed with my Maven projects a little bit, and I created one big Maven project, which is now in one big IntelliJ project, which contains all of the projects that we created last week. So the airline, the student. Actually, I don't want want to files anymore. I want project. There you go. It's got airline and cones and the and the student. So things look a little different from last week. That's why. If you want to find out how and more details on why I did this, go check out that screencast that I put up. So what I want to do at the beginning of tonight, I want to spend a little bit of time just sort of writing some more test cases. Doing some more test-driven development, sort of fleshing out more of my student application. Then we're going to do a little group activity where we brainstorm some more test cases for my for the main method of the flight. Sorry, flight for the student program. And then we'll implement those in what are called integration tests. And along the way, we'll take some breaks and talk about some handouts and things like that. And hopefully, everybody stays awake, myself included. Okay, awesome. So just as a reminder of what we're working on this simple student class. And basically what we're aiming for is something like the following. So we're going to have a main method that creates a student and some of the information about the student, including the name, the gender, the GPA, and what classes the student is taking, all come in from the command line. And ultimately, we want it to print out, let's see here, I think the result of the toString method, which is 2 sentences like the following, that basically takes in this information from the command line and creates this big long sentence here. So we started developing the student class. The archetype gave us a constructor and takes some stuff, and I think we implemented a couple of very simple tests that do things like create a student with a given name and assert that the name is what we expect, and assert that the says method always returns the same thing. So. Now what? What's next? So I'll talk through some of the test cases I have in my head, and you guys should feel free to pipe up with some of the things that maybe you've thought about. Oh, I guess one more thing before we dive into implementation. So how do what constitutes a test case? For me, there are 3 parts of a good test. It's the given, the when, and the then. So the given part of a test or a test case sets the stage. So it's like, given these things are true. So like, given the fact that I've got a student with the name of Pat. Okay, so that sort of sets the stage for the test. The when part is the functionality that you're testing. So when I do something, like here, it's like when I call this getName method. Okay, that's pretty straightforward. Then I expect something to happen. So that's my assert. So I assert. I assert when I call getName on the Pat object. Then the result will equal to the name that I expected. This is the pattern that I recommend that you have in your head when you author your tests. So that given, when, then. It's very simple, and it'll help you sort of get in the right mindset for authoring tests. So, what is our next test? We have implemented the get functionality and the says functionality, and ultimately, so we've sort of get this stuff. So it's this class is too much work, but now let's just implement the rest of this sentence. So he, and it's he because male was passed in, says this class is too much work. So let's see here. Test public void male student has male pronoun. So my given is that I want a student that is a male. So student male equals new student. And what's all this stuff again? So the name doesn't matter. Classes doesn't matter either. GPA doesn't matter, but gender does. What were my rules for my gender? Let's go check that out here. It was mentioned in the documentation. Actually, I can check it out on the, sorry. I can check it out in the API documentation for the student class. Gender. Student's gender, male or female, case insensitive. Okay. So now, okay, so student, what were these again? Oh, I did Command P inside a method call, or in this case a constructor call. It'll tell me the arguments. I think that's also up here. Oh no, wait, where is? I don't remember what the menu is. Yeah, sorry. It's Command P. It's Command P. So for let's do a new array list of classes. The GPA, who cares? 1.23. What we really care. Oops. What we really care about is the gender. Okay, now we say male. So that's the given. So the when is going to be, let's see here, male.toString is actually the thing that then calls, right, toString. Yeah, this is the thing that will describe the student. So this whole, these two sentences right here will eventually be in the toString. But as you can see, we're not quite there yet. So we'll say assert that male.toString contains string. No, it contains. What is that called? Oops. Come on. There we go. Import static method. Maybe it's contains string. What was that called? Well, this is a chance to learn about Hamcrest. Okay, so there. If you guys watch the JUnit lecture, I talk about the JUnit framework for running unit tests, and I talk about something called Hamcrest, which is an anagram of matchers. That is a library that gives you those relatively easy to read statements like assert that something equal to something else. String contains. So you can search for something like Hamcrest string contains, and let's see here. Array contains. Oh, contains string. Okay, there is one of those. So there's a class in the Hamcrest API called Matchers, which has all these convenient static methods that you can then static import into your test to create relatively reasonable, easy to read things like contains string. Contains string. He says. Import static method. Great, there we are. Core matchers contain string he says. So again, my given when then. So given that I have this student here, when I invoke the toString method, then I expect that the result of that toString will contain the string he says. Okay, now let's run our test. I failed because toString isn't implemented yet. Okay, red, green, refactor. Okay, so what's the next thing I need to do? Actually, which color am I at right now? Red. Okay, so what color do I want to get to? Green. Okay, how do I get there? Okay, implement toString. So, what is the simplest thing that I could do to get my test to pass? Return empty string? Okay, I heard return empty string. Will that make my test pass? Nope. It says, okay, I expected a string containing he says, but I was empty string. So it doesn't get my test to pass. What else could I do to get it to pass? He says, okay. And it passed. Okay. Red, green, refactor. Is there anything I can refactor? Not so much there. Oh, you know what? I have this get student named. How about I can refactor that, maybe? So let's see here. I could say, I could introduce a variable. Okay, so I can, so basically what I want to do is say, okay, instead of get student named, I want to say get student with gender. Okay, so now I want to extract, and so I'm going to want that method so I can extract the gender here to be a variable. So I can say refactor extract variable. I'll call it gender. And then let's see here. I can take this whole thing right here and I'll extract a method. And I'll call it get student with gender. And it's smart enough to know that the name of the variable that's sent in is called gender. Duplicates were found, though change method as below has one duplicate. What is it saying? Please make your window bigger so I can read you. Okay, so this is saying, oh, look, I see a very similar, no, what is that? Huh. I have a feeling I don't want to do this. Let's just try, well, now let's see what it does. We can always roll it back. Do I replace that occurrence? Yeah, I'll try. No, I don't. I want to skip that one. Okay, so what did it do? Let's make it big so we can see it. Get student with gender. Oh, interesting. It ended up creating one with like all sorts of stuff that I didn't want. So that's not really the refactoring that I wanted. It was trying to be a little too smart, and that's not what I want. So luckily you can undo. Can I undo? Okay, that's what I wanted. So I think it tried to go an extra step and I didn't want it to. So create me a student with the gender, and there it is there. Okay, so I refactored it. Oh, actually, I'm going to do something else. I don't need this. I don't need this variable anymore. So I can inline it, which basically says take the value of that variable and put it or replace uses of that variable with that value. So basically, what it's going to do is take this and put it down there. That's refactor inline, and says all references yes. So it does this, just one fewer line, and I think this is easier to read. Okay, so I've extracted that that method. Anything else that we can refactor? No, I think we're pretty good here. Okay, so I'm going to rerun my test. Still passes. I'm going to rerun all my other tests just to make sure. And because it's nice and fast, great. That took like all of 6 milliseconds. That's cool. Okay, so now I have this test working. What's the next test that I should write? Female, we've done the male student. Let's do the female student. Okay. So then, female student has female pronoun. Female pronoun. And we're going to create a student with that gender. And we expect that'll say she says. So here again, given when then, given that we have, that doesn't make sense now. The variable shouldn't be called male because that's confusing. We should rename that variable to be female. Great, and so it renamed it here and it renamed the other use. So now, given that we have a student with a female gender named female, when we invoke its toString method, then it should contain she says. We run it, and it fails. Okay, now things are getting interesting. Okay, so what do I need to do here? Well, this the student object needs to know its gender. So now we have some state in the object. That state is the gender, and so then we will initialize that state here in the constructor. So to hold that state, we want a field. So the name of the field will be gender, and its initial value will be the parameter that's passed here in the constructor. So we represent that saying this.gender, so this refers to a field called gender, equals gender. IntelliJ is saying, wait a second, you don't have a field named gender yet. That's fine, I can create one. So through the magic of option return, it'll let me create it. Yes, I want its type to be a string. Notice that it marked it final. Now, what does the final keyword mean in Java? The word static means something else. So I wouldn't describe. So on a job interview, I wouldn't say that a final variable, a final field is static. What's another word though for static that means constant? It doesn't change. And actually, even constant usually means a private static or a static final field is a constant. But yeah, it can't be changed, or rather, it can be only initialized once, and can only be initialized in a constructor. So IntelliJ was smart enough to say, hey, listen, you're initializing a field in constructor. You might want that to be final. I was like, oh yeah, I do. Did something change up here? Anyway. Okay, cool. Now I've got a gender. And so now my student object knows what its gender is, the thing that was passed in its constructor. And then, so down here, what do I need to do? Change it to she says? Oh, okay, I could do that. Can we run again? Yay, passes. Run all my tests. Boo, it fails, regression. Okay, so that was probably not the right thing to do. Let's go back. Let's undo that. Oops, oh no. Did I mess something up? Nope, looks like I'm okay. Okay, what do we want to do?
Create a new member variable that does toString based on the specific gender, so to
Yeah. Oh, wait, say more? Tell me more?
So to key string based on what he says.
Okay, so like,
Clarifying the gender in the string.
right, so I think we want to add some logic here to say if this dot gender, oops, equals male, then return he says, else if this dot gender equals female, return she says. How about that? So I will, oh, thank you. So I will just rerun all my tests again. Oh, doesn't like it. Oh, yeah, missing return statement. Interesting. Okay, what is it complaining about here? I mean, I've got.
It's if else. So it's
Oh, right. Okay. So what do I want to do here?
gender not specified.
Yeah.
Or
Or what? I don't know what I want to do here yet. They, he. Yeah. Yes. And so then, but what is because we're not starting implementing stuff for the real world. What does the program say to do? It says, okay, it says male or female. So like, what should we do if the gender is invalid? Well, maybe it's up to us. So yes, we could implement a neither male nor female exception. For the sake of demonstration, let's do it that way. That's probably not how we would do it in the real world, but I think it might make a a good thing. Okay, so let's see here. Now, is this really okay? And so then, okay, yeah, throw new legal state exception. How about that? Unknown, that seems kind of cold, doesn't it? Unknown gender. And always have a useful error message. Right? Nothing's worth getting an exception, especially when it's you testing your own code, and all you get is like a null pointer exception and no information. Always put in a nice little message. Okay, so we've got this right here, and so now if I go back and run all my this is just my female student. I want to run everything in this. I want to run everything in that student class again. Okay, so that passed. Okay, everybody's passing now. Great. So We've been through red, we got to green, now refactor. Oh, there are a couple of things about this that I don't really like. So these constants right here are like magic strings. Like the same, the word male is here. It's also in the client. I don't like having magic strings. I want to have constants for these. I might have to use this in a couple other places. So instead of just having a string that's here embedded inside one of my methods, I'm going to extract a constant for it. So I'm going to say refactor extract what's called a constant, and call it, sure, male. Like that. I'm going to do the same thing for female. And the keyboard shortcut, I'm going to start using keyboard shortcuts because that menu seems really slow, is Option Command C. Call that female. That looks a little nicer. There's one other thing that I think I can do to make this a little nicer, and that's the following. My toString, I know I've got some more stuff to do there. And my toString has, well, you know what? I'll save that just for a little bit later because I think we'll see. We'll start building up the toString, and it'll get more and more complicated. We'll need to simplify it eventually, but maybe we're not quite ready for that. Okay, let's run all the students' tests again. Great. Now, so all my tests pass. Great. What's my next test? I think we've gotten ahead of ourselves in that we wrote some code right here. We had to write this code. But we don't have a test for that code yet. Right? None of my tests will execute that line. And that makes me feel a little uncomfortable. Even though it's error handling, even your error handling code should have a test for it. So, okay, how do we, what tests do we have to write that will get this exception to be thrown? Yeah, so let's see here. Public void student with unknown gender throws exception. Now, notice the names of the methods that I'm using for my tests. No, I don't. The university doesn't pay me by the character, but I feel it's really important that your tests have very descriptive names. And it almost sort of gives away the given, the when, and the then. So it's like, okay, I have a situation, like, student with unknown gender. What happens? Throws exception. That's nice, and for me, that's the style that works. It's much easier for me to figure out when this test fails, what was going on, what was being tested. So I don't need to go through and then sort of recover what I was thinking about when I was writing my tests. Okay, so what do we need to do here? We need to say student, well, we need to say, let's see here, get student with gender, and then we'll say unknown. And I guess we need to get this as an object, so I'll say extract variable, refactor, extract variable. So Option Command V, we'll call it unknown, and we want to do the following. So when toString is invoked, we expect that it will throw an exception. And the way that you express that except is that you say in your test, you can say the expected exception is illegal state exception. Oops. What the hell is that? Legal state exception dot class. Okay. Okay. Now when I run this test, it passes. Why does that make me feel bad? I just wrote a test and it was never read. Yeah. What should I do about that? Right? So should I go back and have it throw a different kind of exception? Should maybe here's what I think I'll do. I'll run it without this first. So let's comment that out. No, that's not what I wanted. I will. I get to use C-style comments. How often does that happen? Okay, I'll run it like that, and now I should expect it to fail. and it should like spit out that there was a yes, okay, illegal state exception. Okay, that's good. So it is behaving as I expect, and so now I'll make my test pass like this. Yeah. So these are the kinds of conversations that you have with yourself, and it's so nice because I can do it in front of you, and I don't sound like a crazy person, or, well, I do sound like a crazy person, but anyway. But this is like the dialogue that you have in your head when you do test-driven development. Now, you'll notice I'm taking baby steps. It's probably been like a half an hour. Yeah, it's been like a half an hour already, and it's like, oh, we're just getting there. This is on purpose, and it does feel slow. But look what I'm doing. I'm being very methodical about what I'm doing. I'm building up this suite of tests. And if I wasn't running my mouth, I'd probably go a lot faster. So I'll continue on. And what I'll stop doing is using the menus and start using the keyboard some more. When I do my refactoring, that might speed things up a little bit. Okay, so I've got my student, and I've got my toString. Okay, so that was I made it red, it was green, now refactoring. So I reused the illegal state exception because it was easy. Now, illegal state exception is in the Java lang package. It's a standard exception. One thing that I could do is I could introduce a custom exception class. Sure, why not? I think I'll do that. So here's what I'm going to do. Instead of throwing illegal state exception, I'll have it throw an unknown gender exception. And I'll pass in the gender. So I'll create a new class for this. I'll put it in. I'll put it in. I need to put it in the right directory. So it should go in student main. Yep, source main. I'll put it in my package. Cool. I don't want it to be throwable. I want it to be what's called unchecked exception. So I'll make it be a runtime exception. And I'll do the following. Okay, so now I've got an unknown gender exception. And let's see here, student test. So now I'm doing this refactoring. And so now instead of throwing a illegal state exception, I should see my test fail. Yep, it says expected exception, legal state, but was an unknown gender exception. So let's see here. I can change this to be unknown gender exception. Oh, sorry, that was like I deleted it and then just did a new one. I can rerun this again. Cool. Now, are you about to ask, why are you doing that?
Yep.
No, okay, yeah.
I missed something. So when you right-click to create that method somewhere else,
The class.
or
Yep.
class, which thing did you use?
Oh, that was Alt Enter. That was Option Enter, which is the autocorrect. So I typed the name of a class and it didn't know what it was, and so it's like, Clippy comes out and says, "Would you like me to create the class?" I'm like, "That'd be great." Yeah. So okay.
Right.
Someday people won't know what Clippy is. That'll be a good day. Cool. So now I've got unknown gender exception. There's actually one more thing that I want to do here. I want to. So I created my unknown gender exception. I passed in the gender. I didn't do anything with it. I want to do something with it. And actually, just instead of calling it gender, I'm going to call it unknown gender. So, sorry, I didn't answer my own question, which is like, why are you doing this, crazy man? So, one thing to talk about in the lecture is, in the screencasts, is in object-oriented programming, you are conveying a contract between your code and some other code that you're calling. So let's say you're using one of the Java APIs, and so if you look at the Java APIs, the classes that they use, you look at a method. It communicates this contract, things about the contract. So it's got methods. Methods have names, which hopefully are meaningful, so give you an idea of what they're doing. Methods take parameters. These are the inputs to the method, and then parameters have types, which give you an idea of what kind of inputs the method takes, and then it returns something unless it's void, which is here's the output. And then if something goes wrong, it's communicated with an exception. So exceptions in Java are all part of the contract, and all part of the contract that you as a client need to be aware of. So one of the things that that you can do while you're designing your own APIs, when you're designing your own classes, is to decide when to reuse certain classes and when to have custom ones. Now sometimes, like in the case of your flight and your airline, they have to be custom classes. Exception handling, you can make the choice about whether or not it makes more sense to reuse an existing exception and then document that you're throwing something like a null pointer exception or a legal state exception, or whether it's better, whether it's more clear to the client of your code to have a custom exception type to say, hey, when something goes wrong, here's this custom exception that you're going to get that you can handle, and then along with that exception, you can determine what kind of information you want to pass along so that the client who does, the client of your code that does get that exception can know what to do with it. So in this case, I want to augment my exception to make it easier to use by storing the unknown gender, storing it off in a field, and then option enter to create a new field. And then I'm going to let them get to it. Actually, I should have written the test first. I'm going to let them get to that method from the client. So I'm going to do the following. I'm going to say try. I'm going to wrap this in a try catch, and then catch the unknown gender exception. And then I'm going to assert that ex.getUnknownGender equal to, and then I'm going to extract this into a variable called gender. I should probably call it unknown gender. Unknown gender equal to that same thing. There is no method on there. There very well should be. Okay, I can create a getter, which will, I think, automatically just do the right thing. Great, now everything compiles. And I'll go back to the test. Oh, I guess there's one other thing that I want to do. Yeah. So okay, so I go to call my toString, and I expect that this thing that the exception will be thrown, it'll be caught down here, and then I'll execute my assert. If for some reason the exception isn't thrown, then I want the test to fail, and I express that by calling the fail method. And you can give it a message like should have thrown an unknown gender exception, and implement it from that. That is a method from the JUnit API. Now, when I run my test, the test failed because it said it expected an unknown gender exception to be thrown, which is true, but I caught it down here. So now I've changed my test so that even though the exception is still thrown by the code under test, it does not escape the test like it used to. So I can take that out, and I can run that. Cool. So what I've done here is I've made my API, I've made my classes a little richer by saying, hey, there is a custom type of exception to handle and when there is an unknown gender. Yeah. Okay. Kind of cool there. Let's see here. I'm going to rerun all of my tests. Everything passed. I think it's time for me to check in. If I had, where is my version control? There it is. Okay. So what have I done? I've got two modified files, my student test. I've got a new new exception. I'm going to say added support for the gender pronoun. Commit and push that. Commit. Push it up to GitHub. Yeah. I still need to restart to get that. Okay. What else does my toString need to do? Let's go back to this. So I validated the says method. Let's validate this part of the toString method next. So whoever it is says this class is too much work. So new test. Avoid toString contains this class is too, says this class is not enough work, not too much work. Okay, then I have my student, I'll call it student, and I really don't care about the gender. Sure, name student, and I want to assert that student.toString contains string says, what does that look like? I like just cut and paste. This class is too much work. And you see that IntelliJ like put in the backslashes automatically. Yay, get your money's worth. Okay, now I'm going to run the test with Control-Shift F10. And it fails. Oh, unknown gender exception. Check that out. What does the student named? Oh yeah, I have a invalid gender there. Well, that's okay. Oh, that's funny. It didn't. I'm going to change the constructor here to the super for an exception. The exceptions, the inherited constructor can take a message. Here, I'm just going to have the unknown gender be the message. And the reason I want to do this is so now when I run it, the stack trace will include the unknown gender. So that makes it a little easier to read. Okay. That's super weak. So let's see here. I think I want to fix that by just getting a student with a valid gender, because I don't really care about the name. Okay. Now I'm going to run it. Okay, it fails in the way I expect. I expected a string that contains this thing, but it just says, she says. Nice. Okay. So now let's, what do we need to do here? Well, now we're simply not returning a string. We need to build up a string. So how do you build a string in Java? String builder! Yes, very good. String builder. Okay. And return sb.toString. And let's see here. So now we're going to say sb.append. He says, we're going to say sb.append. Oops. sb.append. She says, and then down here we need to append. This class is too much work, right? Yeah. So string. So he says, oh wait, and then the dot append, and then the says method, and then dot append with a dot, I think is how that's going to work. You ever seen this form before where you're cascading chaining the calls to append? Anyway, I don't know if that's readable or not. We'll see. Let's see if it works. So we're red for green. Yay. Okay. Refactor. Any ideas for refactoring? I've got one. How about this? Take the says, which is now, that's duplicate code right there, right? That's, get that out of there. That's duplicate code.
Are you being dry?
Don't repeat yourself? Yes. Yeah. Yeah. So let's see here. Oh, run that. You know, I didn't run all of my tests to make sure I didn't break anything. Let's see here. Is there a way for me to run the entire suite? Run student tests that run all of them? Yeah, okay, great. I'm still green. This is just kind of getting weird. So it seems like toString, this is like separate behavior from the toString. So I'm going to do something like the following. I'm going to say this. I'm going to put a variable. I'm going to call it gender pronoun. And I'm going to move it up. Oh, I can't move it up. Okay, I'm going to move the declaration to right here. And I'm going to get rid of this. Oops. Neat. And so then I'm going to say now gender pronoun. There isn't a fancy, at least I'm not aware of a fancy refactoring to do that. So I'm basically going to say, put all of that into. a variable there, run my test again. See, isn't it nice that like in 11 milliseconds I can just make sure that I haven't broken anything? Now, granted, the logic's pretty simple, but this is the whole thing. Over time, by the end of the class, we'll have a whole suite of these things that verify all the behavior, and they can be run in again a matter of milliseconds. Okay, cool. What is it saying here? If it's replaceable with switch statement. Oh, that's interesting. Meh, we'll see. Okay, so I refactored all that stuff, so this code is a little cleaner. But now I want to do the following. I'm going to take all of this. I want all of this. This logic doesn't belong in toString, right? toString, yes, it needs this, but it doesn't seem like it's its responsibility. I want this to be in its own method. So I will say refactor extract method. And let's see here, get string. No, I want to call it get gender pronoun. There, and I'm going to do that thing where I then inline the call. Okay. Here. Okay, everything still passes. And IntelliJ is saying, hey, you might be able to change it to a switch statement. Let's see. Replace with switch. Meh. I don't know. Is that easier to read? Yeah, I don't know. I think it'd be easier if we just return from here. I don't know. Switch statements always seem like something out of the 70s. Sort of the Frampton comes alive of language syntax. Yeah. Okay. Copy you can do there for. Okay. Oh, sorry. What am I doing here? It is not used, never assigned. So I can't delete it. So let's see here. Unreachable statement. So go away, and then I can just autocorrect and say remove it. Okay, that's kind of nice. Run my test again. Yay, cleaned it all up. Okay. So yeah, that's some refactoring. So this is nice. My toString is a little smaller. What is it telling me here? Oh, can I replace with string? Well, IntelliJ, let's see what you got. Well, that's not so bad, actually. And now what is it saying? Can be redundant, so can I inline it? Ooh, well, that's not so bad. Okay, hey, thanks, IntelliJ. No problem, Dave. I don't know. Okay, yeah, that's easier to read. Right, okay, so you see what we've done here. We did like this method, and this is what happens in test-driven development. Because you're just focused on getting the test working, your code can get a little messy. But if you always refactor, that's why it's read, read, refactor. You do, as soon as you write some more code, you look at the code, it's like, oh, can I make this prettier? Now, it took us a little while to get to the point where our code was messy enough where it's like, oh, I can really take advantage of these refactorings. I can really, make my methods nice and small. But once I did, it's like, oh, this is much more readable, right? And you sort of look at the whole thing, and it's like, okay, I can understand this now. Because I use some smart names and everything. It's okay. I'm pretty happy with this code, and because I'm paranoid, I just want to run everything one more time, and I like seeing the green go by. Yay! Everything's running. Okay, cool. So let's see here. What was the test that I wrote? Oh yeah, right. So add the says too much work. So I'm just going to check this in. Oops. Run my version control, and I'm going to say include. What each student says, what every student says in the toString. So actually, there's something that I wanted to show you guys. So if you looked at, when you watch the screencast that I put up yesterday, I showed off. Oops, where'd it go? This thing right here. So this is Travis CI, and it is now building my code. So I just checked that thing in like 20 seconds ago. Travis has already detected that I pushed something up to GitHub, and now it's running a new build for me. And so it's been going for 13 seconds now. And so there it is, doing all my Maven stuff. So I was working from IntelliJ. I'm just sort of there in my quick red-green refactor loops. And so I wasn't building stuff on the command line, which I probably should have been, but I live dangerously. And so I was just checking stuff into GitHub. Luckily, I've got Travis there watching my back, and so it will go through and build the entire Maven project, build all my stuff for me, and make sure that everything is okay. It's going kind of slowly because it's got to set up a whole It's not a VM. It spins up a Docker container, I think, which runs everything. And so it takes it a couple minutes to build. Let's look at the, oh, wait a second. Let's look at the previous build, though. Build history. It was green a minute ago when I added support for the gender pronoun. And so now you can go and look at the build, and you can view the log of all of the Maven stuff that was happening. And like I said in that screencast, this gives me confidence that I haven't broken anything. And as my projects get bigger and bigger, here again, it's, I've got these like elves working in the background, not making me delicious cookies or anything, but what they said they're doing is making sure that my code still works, and that in itself is delicious. Anyway, it'll run for a couple more minutes. If it fails, it'll send me an email saying, hey, your stuff failed. Yeah, Chris.
Just like a little side question. Why would you ever want to use string builder instead of just concatenating stuff?
Why would you want to use string builder instead of just concatenating? This is a good interview question. Maybe, I don't know if they still ask this or not, but what do you think? Anybody posit some ideas? String is immutable, and that's why you need a string builder. But you can concatenate strings. That gets you new strings, so that's so you can create a string. But yeah, why would you use the string builder API directly as opposed to just using the plus syntax and concatenation syntax? Yeah.
Concatenation also uses string builder, but it has additional overhead. I think so. If you're using string builder by itself, you're avoiding extra overhead.
Yes, in many cases, well, it does. And so the plus operator, when either argument is a string, is string concatenation. I mean, string concatenation in the Java language, and it's implemented using string builder. Yes, it used to be string buffer a million years ago. They changed it to string builder. However, that being said, what we did here, where's the toString method? What we did here is exactly the same code that it was before when I created the string builder. And so here it's much more readable to use the plus operator, and it doesn't incur any other overhead. However, every time you use, every time there's a statement with a plus in it, a new string builder is created. So if you've got a loop, let's say you're looping over a whole bunch of values and concatenating them to a string, you don't want inside that loop to have a plus. If you do, it'll create a new string builder object every time, concatenate the two strings to that, and then append the toString of the string builder to the thing outside the loop. That, at least in the olden days, used to be really slow. I don't know if it's still slow. I'm guessing that the Java just-in-time compiler is smart enough to detect that and to do the right thing. In many cases, however, it's the kind of thing they're going to ask you on, that they might ask you on a job interview. And so sort of say, hey, it's more efficient, especially when you're in a loop, and that'll be the key. It's like, oh, yep, loop, know that. To use the string builder API as opposed to the plus operator. That make sense? Yeah, cool. Oh, is my build done? My build's done, and it's green, yay! Okay, it's little things in life. Okay, so now let's take another quick look at our student. Okay, and so we've done this part of the toString. Now let's take a look at this. Okay, what's the next thing? The name of the student should be in the toString. Okay, that's pretty easy. Student test, public void, name of student is in toString. So let's see here. Student Dave equals get student named Dave. I guess we should probably fix that gender thing. And then we're going to assert that Dave.toString contains string, name, put that into a variable, name. Run that, should fail, yay, right, he says this, okay. So now we will fix that by, oops, there it is, this.name plus, let's put a space. Oh, actually, it'll be like an end of a sentence or something. Oh, this.name. We had one of those already. Oh, yeah, it's inherited from, apparently all animals have names. So, oh, it worked. Anyway, right, this is in the super class, and actually, this is one of my classes. It's in my package. It's not in, sorry, it's in the courses package. It's not in the Whitlock package. And good, it already had one as protected so that I could see it. Oh, that's good. So now when I run it, yay, that passed. Okay, that was pretty easy. GPA, sure. Okay. Name has a GPA of that. Okay, so then, oops, name of student. And now let's just duplicate this. And so you can duplicate with OpenAppleD. Is it, here's, I don't know the menus, sorry. And by the way, every time you, I hope that when you start up IntelliJ for the first time, it gives you that little like, here's the hint of the day. Keep that dialog box open. Like I learned so much just from doing, going through those. It's like 5 at a time. It's really valuable stuff. So GPA of student. Now I need to get a student with a GPA. So instead of Dave, I'm going to call that student, and I'm just going to call it new student. And let's just do all this stuff. The name, who cares? The classes, new array list. The GPA, this is something that I care about now. 3.45, and the gender. Let's just give it a reasonable one. Let's make it female. Okay, and then let's see here. Contains string. Has a GPA of. Oops. Copy. No, did I not? Copy. Has a GPA of, and then the GPA, let's put this into a variable. GPA of a GPA. Okay. GPA. Run it. It's red. Okay. Same thing. We've seen this a couple times already. Has a GPA of this.gpa. Starting kind of long. This.gpa. Let's initialize it in the constructor. This.gpa equals GPA. Let's create a field. Yay, yay, yay. Everything's compiling. Oh, and by the way, I can tell everything's compiling because this little dot here is not red. When something doesn't compile, it goes red. So, like, let's say I have a class that doesn't exist or whatever. It's red with a little exclamation point. And then there are little highlights over here of where the redness is, so you can easily scroll to it. Similarly, when when there are warnings, how do I?
Cut off of our screen.
Yeah, I think your window is.
Oh. So it does. Okay, that's weak. There, you see it now. There you go. Okay, little kind of lame on the screencast. Oh, yeah, thank you. So as I was saying, when things are red, you get a little red icon up here, and here in the scroll bar are the places where it is red. And then when you use autocorrect to make it, that's just bogus. To make it non-red again, there's still some yellow here because there are some warnings. Like access can be private. We'll get back to that in the refactor stage. So we should really keep our what are these things called? Not code. We should keep all of this stuff nice and clean. So remind me to get back to that when we refactor. So I think I added GPA. Nope. Let's see here. String containing has a GPA of 3.45. Has a little GPA. So I guess I should have done a capital GPA because it is an acronym. So let's go back to toString. I can navigate quickly to toString by doing Command F12. I thought. There we go. Command F12 in the right window. I can say toString. Excellent. Very nice. GPA here. And there was a space missing right after this. I think there are 2 spaces because it's after a period. The Oxford English Dictionary would be very proud of me, and it passes. Okay, refactoring. So this is pretty clean right here that we changed, but we do still have some yellow stuff here. What is this thing? Parameter classes is never used. That's true. It will be eventually, so I'll leave it in there. and it's saying that these constants can be private. Okay, that's true. You know, I can make them private because I'm only used here in the class, but probably something better for me to do would be to go back to my test here and replace it with student.female and do it that way. So that way I'm using the constant. That way it's only one. It's only in one location. I could also make that an enum, but maybe we'll save that for another refactoring. So let's go through and actually we will just look for. There we go. So replace that one with male. Oops. Male. Replace that one with male. Oops. Oh, that's interesting. Student.male. Replace this one with student.female. And here's another one. Okay, great. Now I don't have that string, magical string anymore in my file list here. Result of toString is ignored. That's true. Can you do anything about it? I can tell IntelliJ not to complain about it anymore, but whatever. And once again, let's run all of my tests. Great, and I can refactor with impunity because I have all of these tests. I'm going to turn off, let's see here, show ignored, show passed. I don't need to know the individual ones. I just need to know that they all passed. And that way, as the list grows longer, I don't need to worry about there being failures down at the bottom. Okay, awesome. So we've implemented now name and GPA. Let's quick check those in. Implement name and GPA in toString. And let's see if we can get the classes stuff done before we take a break. Let's come in and push it. Okay. Okay, so now we've got name and GPA, and then we've got, okay, taking 3 classes. Those are they. Okay, what do we need to test here? No. Public void. Let's see here. 3 classes are included in toString. So now I've got a student. Student equals new student. Oops. Student, and their name is this. Their classes. This will be something else. They've got a GPA of who cares, and then student female. That's swell. Okay. So now classes. Create local variable classes. The new array list. And okay, you guys know what an array list is? What's an array list? A linked list that uses an array. It's a list that uses an array. It's not a linked list. A linked list is a linked list. But yeah, exactly. So you can go look at the screencast. But the Java API comes with a whole bunch of standard the Java API has a set of what are called collection classes, and these are classes that contain other objects in well-known data structures like arrays and linked lists and red-black trees and hash maps and things like that. And there are also neat properties of them, and you'll be using them in your assignments, especially in Project 3, to store your flights in your airlines. But right now, so basically you can think of this as an object that represents an array, and it has some methods that are easier to use. So, okay, so now let's put some classes in here and put 3 classes. We'll just call it, I don't know, class 1, class 2, class 3. Okay, so now we're going to assert that student.toString contains what? Contains is taking 3 classes, blah and blah and blah. Taking 3 classes. Oh, look at that. put a new line there, but I don't want that. So let's see here. Class 1, class 2, and class 3, period. Get rid of all that. Does that look right? Oh, what is it complaining about? Oh, jeez. Sheesh. Contains string. That's hard to read. It's too long. Let's put it there. Okay. Oh, what is it complaining about? Oh, yeah, there should probably be an array list of strings. Oops. Okay. Let's run it. Okay, fails because it doesn't have that. Okay. Now, I'm looking at this test and it's like, well, that's a valid test. But look at all the stuff that has to be in there. It's like, okay, I got the count, I got this whole thing, I've got an and, I got an Oxford comma. Look at all this stuff. I want to take baby steps, and this is like more of a toddler step. So, okay, let's make it simpler. Sorry, let's make it more simple. Okay, 3 classes. So the number of classes, let's do it that way. Number of classes are included in the toString. Taking 3 classes. Okay, so this is a more simple test for me to implement. Okay, cool. So let's see here. I could do the dumb thing of just appending is taking 3 classes to the toString, but that's kind of bogus. So let's actually just try to implement this straight out. So let's see here. Oops, come on, go. How come I can't navigate into that? That's weird. Student dot. Hello. Huh. toString. Is my keyboard not working all of a sudden? That's messed up. Wow, what happened there? Uh-oh. That's not good. Quick, save the video. Take a break.